Wanted us to cover today is, as I've said, some of the major things that we have covered, and one of these things is all about different translation, different rotations, different scaling factors in OpenGL. And now we will also look at how we can animate things, not just if it's changing the position, not just teleportation, how you can animate from maybe one place to another. So what I'll do is I'll just create a new project, and I'll open my Xcode, and I'll create a new project, a command line tool. So my project, I'll call it OpenGL animation and transformation. Okay, so we look at the different attributes or the different transformations that we have, and the three major ones. Some of what we looked into last time, maybe in class, we majorly looked at the rotation. So I wanted us to see how we can implement that in our code, and how we can maybe animate if it's an object rotating. You can actually see our object rotating in real time, and if it's translating, you can also see it translating in real time. So translation is moving from one place to another. Okay, so that is moving an object from one place to another. We normally have one which is translation, moving from one place to another. After translation, we normally have, what do we call it, rotation, rotating an object by some degree. So we can rotate by some degree, or pivot and pivot. So you can rotate around a pivot, you can rotate around yourself, and number so we have scaling, changing the size of the object, either smaller or larger. So we look at how we can implement all these, and for a start, I think we can start by translation. We can start by translation, and this is moving one from one place to another. So we can have maybe a triangle, or a square, or a rectangle, or any shape that you would want to create in your program, and then we can move it from one position to another position. So we'll start by having our preprocessor directive that will say include GLUT, then you say GLUT.header. So this is a preprocessor directive that will import the GLUT library. That is the use of the hash include. So now by doing this, we can now use all the OpenGL functions that are provided by the GLUT library. And what you need to do as the first thing, so we have said that we will do what we have said, that we will translate, or we will move an object from one place to another. And now to do that, we need to define a couple of things, such as the dimensions of what we need to move. We also need to define the transformation or the translation factors for both x and y, like how will it change with regard to x and the y axis. So I think the first thing that we need to do is to define the initial initial position, okay, initial position, and the translation factors. And to do this, we'll define them as the floats for the translation factors. So just think of the translation factor as how it will change along the x and y axis, because for translation the position has to change for both x and y coordinates of our or whatever we are doing. So we'll have the float for the transition of x, translation of x, I mean, and we can initialize it to 0, 0.0. And also we have for y, the same case for y. So you can say for y is also 0, 0.0. So it will start from 0, 0 to the also y, the initial position is 0, 0 for both translation for both x and y. And we also do the now the change. The change is normally the magnitude. We normally say the change in x and the change in y. So how does the position change in x, and how does the position change in y? You remember, like when calculating the gradient, there is that slope. Okay, there's a slope when you're calculating the gradient. So in this case, we're looking at how it will change in x and how it will change in y. So this will be like the increments. So you just say maybe you can initialize like for the x to be 0.1, and it will be changing by y also by 0.1. So think of this as the gradient in which we are going to be translating our object. If it starts from somewhere here, in terms of x-axis, we are going to be changing by 0.1, and also the change in y will be 0.1. So these will be used as we can say the increment for updating translation factors, the translation factors. And we can say that the tx and ty is there. These are now the translation factors for x and y coordinates. So these are the translation factors, the tx and the ty. Now what you need to set up first is our rectangle or our shape, that in this case I think we can use a simple square. To use a simple square, we need to first of all define it. We need to define how it will look like, define how the setup will be. You recall we were setting maybe the background color, we were setting the foreground color, all those things. Okay, and also we need to define maybe the color that we will be using, all that. So that is done in there. We can create a function to set up the rendering context. So this will set up the rendering context, and this is setting up things like the matrix mode, the color you want to draw with. So you can call it something like void initialize init or initialize. And in this function, you start with set the background color. So you set the background color to black. And to do this, it's just simple. You just say GL clear color, and by this you just give 0.0 for RGB. So 0.0, 0.0, and also for blue it's 0.0, 0.0. That is now for all of them. And the alpha, you can also set the alpha to be, also the alpha can be set to be like fully 1. So you don't mind about the alpha. Just know that these are the ones that now define the color, the red, the green, and the blue. So that is what will be used to define our color. And then this is the background color. And then to set the drawing color, you say GL. Okay, let me just say set the drawing color. And in this case, we'll set to color white. So to set the drawing color, just say GL color. And then it's a 3F. Then you say for to define a white color, you normally now have all of them as 1. As you can see, for black, all of them were 0. Now for white, for the red channel, the green channel, and the blue channel, all of them are set to black. Okay, so for this function, you don't have to set the alpha, but for the clear color, you can set up the alpha. Let's see whether you can do without setting up the alpha, and I think you can also do that. So you can see it's not too few arguments. That is telling you expected 4 arguments. So actually, for the GL clear color, you have to set the alpha, and the alpha is a value between 0 and 1. So you don't have to worry much about that. Just know that now these 3 are what you're going to define your color with. And these 3, these are the drawing color. And in this case, we are saying it's color white. So let me just get rid of these warnings. And if I want to get rid of these warnings, I can say define GL silence deprecation. So I can copy this code and paste it here and say hash define GL silence deprecation. So that should get rid of these some of these warnings, and I don't know why it's not getting rid of them, but I think it should in a few moments after it compiles. So let me just try and run my program, although for now it's not doing anything here because I even don't have a main function. So the next thing that we are going to set up is the matrix mode. Okay, set the matrix mode. So these are the basic OpenGL stuff that you always have to do. So you say GL matrix mode, then it should be GL projection. These are the basic OpenGL stuff, and I think there's a message. In case of anything, are the codes examinable? I'm not quite sure about that, but I don't think you'll be told to, especially like when you're writing the main function, I don't think you'll be told to write all that. But what you need to do is you need to know, you can be asked which is the function that sets the drawing color, and you need to know it's something like the GL color. If it's initializing OpenGL in polygon mode, you say it's normally something like GL begin, then you say GL polygon. So those are some of the things you can be asked. Actually, you can be asked, but I don't think you can be asked to write code that will implement all this. What you're normally asked is if it's, in this case, what are we doing? We are doing translation. You'll be asked to do translation the mathematical way. Okay, the mathematical way where you actually do the calculations, like how we did our matrices in class. So that is mostly how you are going to be asked. But you need to know what these functions do. To if it's something like if you wanted to draw lines, you need to know that the function that sets OpenGL to draw lines is GL begin, GL lines, such things. So you need to understand, but I'm not sure. I have never come across that, but I don't know. I hope it doesn't do that. But you might need to understand some of that. Is why for every line of code, I'm writing for you comments on what that code does. Okay, that's why I'm writing for you. So here you define the projection. So these are the basic OpenGL things that you have to do, and in this case we will use orthographic projection. Orthographic projection, and to do the projection setup, you say GLU orthographic, and that is it. So let me just get rid of this. Orthographic projection for 2D, and can start from maybe negative 10 to 10, and then negative 10 to 10, negative 10 to 10. So based on the function GLU author 2D, so you can see you should provide this defines the left, the right, the bottom, and the top. Okay, so these will be used to set up our projection on the left, on the right, on the bottom, and on the top. That is what the author 2D projection does. And yeah, that is it for our initialization setup. That is the initialization setup. So the next thing that we could do is now the display, right there, the display function. This function is the one that is called from the main function to display on the screen. So you say this was the init function, and now what we need to do is the display function. So we just say void display. And now for the void display, the first thing you need to do is, if there was any color, you clear any color. If there clear any color with the background color. So you just say clear the screen with the background color. And this is the normal clear function, so you just say gl clear. So these are some of the things you can bear. So you say gl color buffer bit. And what this function does, it clears the screen with the background color. So it will preserve your background color, but clear any other that might have been declared or defined. And then the next thing that we need to do now is to apply translation to our object. So the translation, you recall we defined these things up here, and we said that the tx and the ty are the translation factors for both x and y coordinates. So how it will be changing for x and for y. And now how can we do that? To do that, so the first thing that you need to say is gl push matrix. So what does this function do? So this is a built-in function for OpenGL that will save the current transformation matrix that we have. So this saves the current transformation matrix that we have. Recall that how we were defining our matrices. We maybe had a start matrix, like how we were doing rotations. We had our object matrix. So our object can be defined by a matrix of different points. And this is what will save those transformation matrices that we have, and not just for those, but for every current one that we have, because this display function, it's actually called in a loop, because you'll see that at the main function we normally call gl main loop or whatever we call it. So you will say, and the next thing that you need to do, you now translate. So you say gl translate translate, then f, and this is actually translating using a function. Okay, using a function. So we are not translating manually. How you can translate manually is now you do all those math calculations, like how you can do it physically in a piece of paper, where you calculate and store your values in a table. So here we are going to use this function, and now use the translation in x and the translation in y. So you say the translation in x and the translation in y, and then you say 0.0 f. And what this does, this will apply the translation by tx and ty. So that is what we'll do that. And what are we now translating? We haven't yet drawn our rectangle. So we have to draw our shape that we will be translating. So you need to draw a shape, and you say gl begin. And then this is what I was telling you, gl polygons. Polygon. This is what I was telling you. Something like this, you need to know about. If you need to draw a polygon, you say gl begin, and then you have to provide it with at least 3 points, because a polygon, the least unit of measurement of a polygon, we can say it's something like a triangle. So the number of points that can be used to make up a shape that is joined. So 2 dots can only make a line, and 1 dot can just make a point. So GL begin, if you wanted to draw points, you say GL points, or point of points. So points if there are many. If you wanted to draw lines, you say GL begin, GL lines. But in this case, we need to, I think there's also line strip. Line strip, yeah. Line strip, line loop. Okay, so these are the different modes that we can begin our what I think there's an echo. Someone is, so you can mute your mics. Yeah, thank you, John. So what I was saying, let me just get rid of this infinite mirror. What I was saying is something like GL begin, you really need to understand what this function does, because you can be asked if I wanted to, or you be given this function in an exam and be asked GL begin, GL polygon, and be asked what does this line do. And what this line does, it initializes OpenGL to maybe display polygons. Okay, so this means that if we provide different points, it's a polygon that is going to be drawn. If it was GL points, if we provide now different points, whatever will be drawn will be just points. If it was a line, GL lines. If we provide different points, or like 5 points, it will just draw lines. It will just draw lines. But now if we say polygon, it will actually draw a polygon. So just think of a polygon as a shape. And one of the attributes of a shape is it can be filled with color. It can also be filled with maybe other different factors that can define a polygon. So in this case, we need to draw something like a square or whatever. So by drawing, we just provide, we need to provide the vertex points of what you want to draw. So we need to provide the vertices. And to provide now the vertices, you just say GL vertex 2F. And these are some of the things that now could be asked. You could be asked, what does this function do? And this function is used to now define a vertex point, and you provide it with the x and the y. And the reason for that is because here it's number 2, so we are providing 2 points. So we need to provide for x and for y. So we can say x is something like negative 1.0 f, and y is negative maybe 1.0 f. These two. So we can also have something like GL vertex 3f. So you can see, you can have something like that. The difference between this is that the first one, you are providing 2, and the second one you are providing 3, and now for 3 it's normally x, y, and z. And the reason for this f here is because whatever the value we expect here inside, those two values for x and y, they should be floats. They should be floats. We know the difference between a float, a double, an int, those things. So it should be a float, because you can write something like gl vertex 2d or 2I. Okay, so for 2I, you can see it's actually an int. Okay, so you say gl int and gl int for I. And you can also write d. So you can also be asked, why am I writing here d? And for d, you can see it's because it's a double. So you say gl vertex to d, and we need double x and for double y, and the same applies to 3. You can say 3d, and that will be x, y, and c, and z, and all will be doubles, x, y, and z, and all are doubles. So these are the things that you actually need to understand. But in this case, since we are just drawing a simple rectangle or square, we just need the values of x and y for our vertices. And the next vertex we can draw is gl vertex 2. Am I using 2 what? I'm using 2f. So 2f, and then what are the coordinates? You can say 1.0 f and negative 1.0. So think of these as this is the maybe the bottom left, and this one is top left point. And then we go to top right, gl gl vertex 2 f, and then top right you can say 1.0 f, and then also 1.0 f. And the reason why I'm having this f at the end is because we are using a float. So it's normally used to denote a floating point number, but I think it's optional. It's not a must you write it, so you can have it like this. It's actually optional, but it's normally recommended for you to know that you are dealing with a floating point number or decimal place number. So let me just return the f, but it's actually very optional. You don't have to write it. If you're given an exam and told to write, you can write it optional. It's also optional for you, so you just write it if you want. If you don't want, it's all up to you. And gl vertex 2f, and the last point is negative 1.0 on the x-axis and 1.0 on the y-axis. So these define our rectangle or our shape. This is a square. As you can see, we are just revolving around the 0. So we say negative 1 to 1, 1 to 1, negative 1 to negative 1. So that is what we will do to now draw our polygon. And after doing that, we now end drawing the polygon. So you have to end drawing the polygon. And the function that we normally use to end is just the same thing, gl end. So these functions actually you can just have a hint of how they are named. So like gl end is used to end drawing the polygon, not just the polygon. We're saying the polygon because we started drawing polygon. If here we are ending had started with GL lines. Now this GL end, we would say end drawing the lines. So that is the use of the GL end function. And remember here we pushed a matrix. So after pushing it, after we are done drawing, we need to get rid of it. So you just say GL pop matrix. What this will do now is it will now discard and restore the previous transformation matrix. So this will just do the opposite of whatever was done here. So this was a push and this is a pop. So pop is to remove. And then the last function is normally where the OpenGL command ends. And it's normally GL flash. And what does GL flash do? This one, it forces execution of OpenGL commands. So the GL flash, it will just force the execution of OpenGL commands, and those commands are just all these OpenGL different commands and some other commands that happen in the background. GL flash will ensure that they are executed and everything is executed perfectly. So that is it with our display function. And now the last thing to write is the main function that will also call the display, and also will also use the initialization. But since we are actually animating, we can have another animation, not another animation, just another function that will be used to update the translation values now. So this is the function that will be used to animate. So in this case, the animation will move the object from one point to another. If you are to draw this display function, it would just display just a rectangle. But since now we want to move it, we can create a function that will actually be used to move the whatever we have drawn here. What do we call it? The square. This is a square because you can see it's moving from -1 to -1, -1 to 1, 1 to -1. So that just means it's that function that will now be used to move. And you can just call it something like void move or idle. So we can just call it an idle function, or move or whatever. So, and what this will do, conflicting types for move. Do we have another thing that is called move? I think we cannot use the move keyword, so we can say idle. So what this will do is that it will increase the values. It will update the translation factor for both x and the translation factor for y. You can see that they are starting at 0, 0. So these are just the translation factors for both x and y. And now what this function does, it will update the translation factors for both tx and ty. And that is what you're going to do. So you first of all update the translation factor for x. You say translation factor for x is equals to the change in x, and the change in x is defined as dx. So is equals to dx. And also the same thing for the translation factor for y is equals to dy. Those two. And lastly, we need to do what? We need to if our object is increasing in terms of the x and the y, there has to be certain bounds. So like if we are coming from this point here, if you are coming from here on the screen to here, up here, definitely we have to define the bounds that you should not go below -5 and you should not go above +5. So you need to create bounds for where you want to move. So if you want to move like that, you need to have bounds. If you exceed this bound, I set your position to where you are so that you cannot exceed that position. So you need to define the boundaries that should not be crossed by the object when it's translating or moving And so how can we define the direction? And we just say that if our transformation in x is greater than 5.0, so if we go at a point that is greater than 5.0 or a point that is less than 0, not less than 0, tx is less than -5, -5.0f. So if we go at a point that is greater than or less than, so if we maybe exceed somewhere like here, we go beyond that, or we go at somewhere that is now less than 5.0, what do we need to do? We need to alter this change. So if we were going up to here, we need to reverse the change. Okay, we need to reverse the change. And how we can reverse the change? You just say dx. You say the change in x is equals to, you negative it, you reverse it. So this will be used to negative the change. So if you are increasing a number in x, if you want to go back, what do you normally do? You just subtract. Okay, so it's just the same concept here. If we get to a point that is beyond 5 or a point that is less than 5, we reverse whatever was there. We just reverse it, whatever was there. And the same case for y. So you can see we are dealing here with x, and it's the same case for y. So you say if ty is greater than 5.0f, or the translation factor in y is less than -5.0f, what do? We say that dy is equals to negative dy. And that is it. And after we are done with this, you request to redraw the screen. because we have updated the new position. So you need to request, so we just say glut post redisplay. Okay, so these are, I've never seen people using this function, so these are quite advanced. I don't think you can be asked on this. So you say you request to redraw the screen, but if for your knowledge, just know that if you want to request to redraw the screen because we have updated the new position, you normally use the GL GLUT post redisplay. The GLUT post redisplay. That is the function that is used to request to redraw the screen. And yeah, this is after we have updated the position, and now the main function is now where we call everything. So you just call everything now in your main function. So the main function, this defines the entry point of our GLUT program. So this is the main function. This is where everything will now start. So you just say int main, same thing. Then you say int argc, and then character array, character pointers argv. And these are what are normally used to initialize the OpenGL library. So the first thing you do is initialize the OpenGL library. And to do this, you just say glut init. Especially now, these functions that are in the main function, what you are writing here, this is what you can actually now be asked. So you say and rgc, then rgv. This will be used to initialize the OpenGL library, the glut init. Then the other one is what we normally do next is to set the display mode to single buffered. So you set the display mode to single buffered, and also add the color scheme and color scheme. Mostly it's in red, green, and blue, RGB. And how do we set the display mode to single buffered and color scheme? You just say glut init display mode. That is the function that is used to do that. And then you say glut single buffering, and the color scheme is glut RGB. So this function is used to set the buffer mode and the color scheme. So here is where we are saying that we are going to be using the RGB, and they are the same colors that we were using here, where like here where we are defining our colors, we say GL color 3F, and that is the function that is used to set the display mode. And then you set the initial window size. So after you set the display mode, and these things have to follow sequentially, like how they are following here. You first initialize, you set the display mode, and then set the window size. So how large will your window size be? And to do this, you just say glut init window size. And for window size, you just give it we just give it the x and y. How long is it gonna be on the x-axis? So just think of it as the length and the height, and in this case we can give it a length of 500 and a height of 500. So it's also a windowed square. And after that, you can now set the window position. Set the initial window position. So this is the position that our window will be displayed. For this case, you can think of it as if you launch an app like calendar, you can see that it's displaying at so let me just minimize it a little bit so that you can understand what we mean by the window size, not the size. Okay, the window size is now what I'm doing. So I'm increasing the window size. If it's the window position, this is now changing the window position. And the initial position is when I run this calendar app, where does it display itself initially? So let's say I leave it somewhere like here. So let us see whether the calendar app actually saves that last position. So I open the calendar. So yeah, it doesn't. So for the calendar, they have said that the initial position of the calendar has to always be the default one. And the window size of the calendar always has to be the full screen window size. So if it was not the same for certain apps, if maybe I was to close the calendar and open it again, you would tend to find that it would preserve its previous position that I had closed it at. But now you can see it's resetting everything by default. And now what OpenGL gives us is the freedom to set the initial position of our window. In the initial position, we can just say GLUT initial window position. Initial GLUT GLUT init window position. Init, not initial. So you just say init window position. So this is the initial position. Where do you want it to be initially? So you can set the position to something like 100 by 100. That is the initial position. And the size, don't confuse the size and the initial position. So the initial position is when you run this program, where exactly on our screen do you want it to appear? And where I want it to appear, I've told it I want it to appear at the coordinate x 100 and y 100. So this will just define, just think of it as also something like a vector, an x and y vector. But the window size, this means that the length should be 500 and the height should be 500. And after setting the initial window position, you can now create the window and give the title. Create the window and give the title. And to create the window, you just say GLUT create window. And the title, you just do double quotes and say OpenGL class translation movement, translation animation. So you can just say that is your title. And when we run our program, you'll see that this will actually be our title of the window. So create window, and then the other thing that you need to do, you can now initialize. And by initialize, what I mean to do is to you can call this function. So if you do not want to use an initialize function, you can write this code in the main function here. Okay, you can now write this code here to set the background color, to set the drawing color, to set the matrix mode, to set the projection. So these are the basic things that we normally do in initialization. But since we have a function that can execute all that, we can just call this function init. And in here, we can just delete all this and now call that function init, that is called init. So you just say init, init, init. So that is the initialize. So this will initialize things such as what is it initializing? The color, the background color, drawing color, matrix mode. So this will background color, drawing color, matrix mode, and lastly projection. This is what the init function does. But if you did not want to do it in a function, you can actually just copy all these things and then paste them on your main function. And after you initialize, the last thing or the thing that you need to do is to call the display function. Now call the display function. And how do you call the display function? You just say GLUT display function, just like that. And the display function is whatever was being used to draw. Whatever was being used to draw, in this case GL polygon, how we cleared our buffer bit. So you just call this display function and say GL display function is called display, and that is our display function. And after display function, don't forget that we also have this function that is animating now, that is updating the position or the translation factors. So we also need to call this idle function. So you just say set the display. So this is used to set the idle callback function. Idle callback function. This idle, the function that we created here, that was requesting to redraw the screen once the position has been changed here. So we just say GLUT idle function. The GLUT idle function is called idle. And as you can see, it's just that. And after that, go to the main loop, or call the main loop. And what does it do? This is normally the GLUT event processing loop. So this is just a very basic loop for OpenGL, and it will always remain like that. So you just say GLUT main loop, and then you have finished, and then you return 0. And yeah, this is how we can create our program to display, to translate, okay, to translate a given object that we have defined here. So let me just run it and see whether we'll have something. So let it run, and awesome. Look at what we've created. So now this is what we have created, and as you can see, it's actually going in like a slope from bottom to top. So let's try and mess up with some of the values. As you can see, our window size is actually a square. So let's try and see if we can make it a rectangle. And to make it a rectangle, the window size, this is the window that I'm talking about. This one right here, this one here, this is a window. So I want it to be something like a rectangle. And we said what defines the window size. Whatever defines the window size is what we have here. So here we are saying for x, have a length of 500. If I wanted it to be longer, I could say for x, have 800. And for y, have 500. So let's see how it will behave. I expect it to have a longer length than height. And as you can see, it's actually that way. And it's even affecting our square because we have given it an unproportional length and height. So as I change this, you can see it's actually also changing our object that we are animating. And another thing is that I can just have them like 1,000 and 1,000, 1,000 and 1,000. So 1,000 and 1,000, and if I run, this should give us a, as you can see, it's actually a larger window. And I think it's because the y should not reach 1,000. So let's just write something like 800 by 800. So I just wanted to make it bigger and also a square. And the initial window position, you can see it's actually now better. So let's try and mess up with maybe something like the background color. And where are we setting the background color? Here in the init function. And let us go to the init function. The init function set the background color to black. And we say this normally defines the red, the green, the blue. So if you don't provide anything for them, it will default to black. So let's say RGB. So let's say if I wanted it to be green, I could have said maybe clear color, then 0010, and then 00. Let's see whether that will work. Oh, awesome. And as you can see, our background color has changed to green. And let's say we need our background color to be green, and the shape, the circle that it's a freaking square, the square that is drawing to be red. So this is what defines the drawing color. In this case, we are using color white, and color white is represented as 1, 1, 1. So you just provide 1, 1, 1 for both RGB. And if I wanted it to be just red, I could have said red to be 1, green to be 0, and blue to be 0. So I just say 0, 0, and 0. And we expect that our background will be green, and our drawing color, our square, should be red. So let's see. And as you can see, it's actually working as expected. And if I was to change that background green to blue, I would have said 0, and then here blue RGB. So blue, I give it 1. And as you can see, it's a blue background and red foreground. And I think blue is just so shouting. I would prefer green, so we can do it green. And if you wanted to provide another color, such as, I don't know, magenta or what, you can say blue and green to be one. So let's see what color that will produce. So with this RGB, you can be able to produce any color. So I don't know which color is this. I think it's cyan. Yeah, it's cyan. So you can see this background color is not actually green, it's not blue, it's not red. It's another color, and it's because I have provided one for green and one for blue. I think that forms cyan. If it was magenta or whatever, you can use to define those colors. And if I wanted our cube to be bigger, I think I can increase here to be -1, -2, from 2 to 2, 2. I just change these to 2's, so that you can see that our shape should now be larger. As you can see, our cube is now larger. And let's say I wanted to do what? Okay. Can I have like two of them? But that is so much work because we'll still have to write some code. But that is how you can do that. And if you wanted to decrease the bounds, let's say your bounds to be something like maybe 2 and 2. So it's going up to the topmost point of x, which is 5, to the least point of x, which is -5, and also the same for y-axis, -5 and 5, -5 and 5 for both. So what I want to do is stop that and maybe decrease this to something like 2 and 2 and 2 and 2. So I have minimized the bounds. I have minimized the bounds of where our object was traveling to. So let's see how it behaves. So recall that it was going from the bottom to the top. So now I have decreased that, and the problem is that I think this is still the odd one that hasn't updated. And let me open my code blocks, and yeah, there's still another one that is running. I have so many. Yeah, you can see now this one has a very lower bound of range. It has a fewer range of where it can go, and if you are to decrease it further to 1, you'll see that it will actually change to that. So my bound is like that. As you can see, it's going from -1 to +1. And to make it go from top to bottom again, you can give it a value like 6 and 6 and 6 and 6. Then when I run my program, you'll see that it's actually going a further distance or a further range. So think of this as how the the DVD, the iconic DVD video was normally done. So there was that waiting screen or that screensaver for the DVD where it used to go hitting these corners. It hits such a corner and then goes back, hits another corner, reflects to the other side. So this is how you can create something like that, but now from scratch. Okay, from scratch using now the OpenGL and some math functionality. Yeah, so we've also not checked at the title. So observe the title of our window. It should be named OpenGL class translation animation because we are using the GLUT create window and providing that as the title. That is if you are asked how you can change a title in OpenGL. So if you look at the top here, you can see it saying OpenGL class translation animation. And yeah, this is it's actually hanging on. Yeah, so I have now deleted that. And as you've seen that, that is how the title can also be affected. And I would think that is it. That is it for today. What I can do is I can send you this code. As you can see, I have done what I have commented every line of code and what it does. I will share this code just like the way it is. So I'll select all and copy, and I'll send to Pascal to share with you. Yeah, so I think this should not be here. It will affect if you try to run your code. It might affect, maybe your machine doesn't support it. And also for your machines, I saw that it normally starts with GL, GLUT. The reason why something like that might be different is because this is a totally different operating system, and the way it's set up here, it's different from the way it's set up on Windows. So for Windows, you normally write here include GL, GLUT, or I think there's a simpler way that Windows does it. But for here, you have to write GLUT because the folder is named as GLUT, but yours is normally named as GL. And yeah, that is it for that's it I think for today. I don't think we'll be able to cover the rest. I'll share the code for the rest of how you can do now the maybe rotation, because for this we have just translated it. So I'll share the code for rotation and the code for scaling, how you can do those operations. And yeah, I think that's it for our lesson today. I might welcome now any questions. Or let me see whether there were some on the chat. So for the codes, I don't think you can be told to write such a program. I also wouldn't be able to write all these in an exam, just like remembering all these. It's I don't think you can be told to write. So this is for demonstration purposes and for the practicals. For the practicals, you definitely have to write, because even for the assignments and the practicals, you just have to write something that has an output and something that you can actually see, or just see how computer graphics work. And so for what you might be examined, or what you should, especially what the contents of the main function. What is happening here? What's happening here is you need to understand, because you can be asked the function that is used to set the display mode is the GLUT init display mode. How do we set up the window size in OpenGL? You say GLUT init window size, and then you provide the dimensions for the length and the height. And yeah, that is it. That is it for the lecture today. Are there any questions? If there are no questions, I think we can end it at that. And I will share the code with you if you wanna check it out, and also the video if you want to check it out and follow along on what we covered.